I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline.
This episode of Industry Insights and Trends is brought to you by Parker Hannifin.
Sustainability is no longer marketing hype. It's a fundamental part of the way machines are engineered in the 21st century. The electric vehicle revolution is in full swing in the automotive industry, but internal combustion engines power a lot more than on-the-road vehicles. Equipment in the mining, construction, and agriculture sectors is big, powerful, and emits both pollutants and CO2 from internal combustion engines. I'm joined by Electrification Product Manager for Parker Hannifin, Jonah Leason. Jonah, welcome to the podcast.
Hey, thanks for having me, Jim.
There's so much to talk about here, but could we sort of put a frame around the conversation, ask ourselves something pretty fundamental, which is, what do we mean by sustainability in the context of these off-highway machines?
Yeah, that's a good question. So these off-highway machines are commercial vehicles, so they're meant to facilitate commerce. They've got a job to do. They're a tool that a business applies in order to generate revenue or increase the GDP, we'll say, at a very high level, or the gross domestic product, make money, facilitate commerce. So in the electrification of these off-road equipment, it's really important that we keep that in our mind, because there's a lot of societal and political pressure to electrify things for multiple reasons. It could be to reduce pollutants, to increase air quality. It could be to reduce carbon. So all of that said, sustainability for a commercial vehicle, an off-road piece of equipment, an excavator, materials handling, it's critical for sustainability that it fits within that business practice and it's not having a negative impact on that revenue generation.
Yeah. Now, we talk, of course, a lot about reducing CO2, and CO2, of course, being a critical greenhouse gas. But if you sort of cast back to sort of the early 60s, when the California Air Resources Board stepped up, and they originally, I believe, were going after things like photochemical smog in the LA basin, and started a series of regulations that were unique to California and later were adopted, by the EPA for gasoline-powered internal combustion engines and latterly for diesel engines. So we talk a lot about CO2, but there's a lot of other things going on in terms of emission from internal combustion engines.
Yeah, absolutely. So regulations today are still based on reducing pollution or respiratory irritants. What we see in the on-road sector is we're starting to see more and more greenhouse gas, which would be carbon, CO2, carbon monoxide, carbon dioxide release. That happens when we break up complex hydrocarbon chains like in fuels. So any of your petrochemical fuels are hydrocarbon based. In combustion, you break the hydrogen and the carbon bonds and you get a lot of CO2, carbon monoxide. So originally regulations were rooted in respiratory health. The way that they regulate greenhouse gas, it's still, we'll say, an environmental pollution. It's known to be changing the environment, but greenhouse gas regulation is really around fuel economy regulation. So we have both now. So we have both, NOx, particulate matter, and now greenhouse gas emissions affecting both on and off-road segments.
Yeah, it kind of drips of irony. I recall talking to an engineer at one of the big three once who said that, one way that we knock down CO emission, of course, is to convert it to CO2, which in a way kind of actually increases the carbon load.
Yeah, and actually the ocean does a good job of absorbing a lot of that CO2, but there are saturation limits. And what we see is pH levels are increasing in the ocean, and that's due to that CO2 absorption.
Yeah, folks that are fans of the internal combustion engine and really want to keep those machines going, they're talking about some alternative pathways to CO2 reduction. One, of course, is sequestration, which is you just suck the stuff out of the air and lock it in geological formation or inject it into oil fields. Various ways to do that. Another, of course, is synth fuels. Is basically just we'll find a way to make the fuels in a way that sort of pulls CO2 out of the net, so that you're net zero CO2 emitters. Are these practical ways forward?
I've looked at synth fuel a little bit. It doesn't, I wouldn't say that it's sustainable. It's sustainable in some ways, right? So mobile equipment requires very energy dense fuel, that batteries, diesel, gasoline. The energy density is critical there because you're carrying it around everywhere that vehicle goes. And so if we look at it from an energy equation, it's not really sustainable because to generate enough CO2 to synthesize fuel, you're at a net negative energy balance, which means that you're going to put more energy into creating that fuel than you are when you burn it or combust it. So I wouldn't say that that's necessarily sustainable. But if we look at it from mobile versus stationary, you can get more efficiency out of stationary power generation. Stationary has its own net benefit for efficiency. So you could argue it, but I wouldn't say synth fuel today is sustainable.
Yeah, yeah. And of course, it's one thing that I mean, the corn lobby in the Midwest for years have been talking about is let's go ethanol. Let's blend more of it into motor fuels. Let's go 100% ethanol if we can. E85. There's a lot of talk about that. It's you talked about the energy balance of that, but there's also the other question of is it does it make sense to grow food and then burn it in the fuel tank?
Yeah, no, when you're doing anything to negatively impact food cost, especially to the end consumer, it's generally not going to win. We should be prioritizing our food for people, livestock, things like that, rather than prioritizing that on fuel. But there's been a lot of research into like algae generated oils. Again, not a food competitive source. And also, it's a very controlled generation and harvesting that you could, again, because it's stationary, you could set up solar, you could set up wind to power those things and make them more sustainable.
Yeah, yeah. Now you mentioned societal costs there, but because of course they're externalities from a cost perspective in anything that involves the kind of things we're talking about with these machines in there. There are some that argue that you actually reduce overall healthcare costs because you have lower incidences of things like respiratory ailments that come out of this. So is that something that you can kind of factor into the cost of electrifying, internal combustion engines?
Yeah, it's tough because it's distributed, but generally, there's a mindset out there that electrification's too expensive, the infrastructure's too expensive, the vehicles are too expensive. But if we look at it, I think it was the American Lung Association says 4 in 10 Americans live in counties with unhealthy levels of air pollution. Now, if we look at that, it really means people living in cities, right? So people living in cities have unhealthy levels of air pollution. And so a lot of, the 6 out of 10 people that don't experience poor air quality don't really have that frame of mind. Like it is important, right? But these are shared costs. So our healthcare systems, especially in the US, I mean, you really have shared costs in Canada, but in the US, taxpayers do end up paying for healthcare for people that don't have privatized healthcare. So it is a shared societal cost, and it really adds up. So I think some of the numbers I read was somewhere between zero point 0.9 and $2 trillion in healthcare expenses from on-road commercial vehicle emissions from 2014 to 2030.
Yeah, yeah. So basically, I think we've framed it up so this progress toward electricity makes sense. It's a question for you, and that is it's from an engineering perspective. Very, very large and heavy prime movers have been hybrid in the sense they've been diesel electric typically for a long, long time. If you want to move 200 tons of railroad cars, basically the most efficient way to do that appears to be to have a big diesel engine spinning a generator and driving traction motors. We've also seen that in very large off-highway equipment. Some of the very largest mining equipment is diesel electric as well. I think things like walking drag lines are all kinds of very big power applications where even if we're getting battery electric, there's a reason to use electricity as the source of propulsion. Why is that? Is that just about power delivery, control, efficiency?
It's really all of the above. So one, we'll talk about in-ground mining for a second. So in-ground mining, they have to have ventilation in order to get internal combustion emissions out of the mine. And that could be 30 to 35% of that mine's operating cost is in ventilation. So then if you're removing the internal combustion from in the underground mine, you've got a positive business case to electrify that equipment because you've just saved 30% on your operating costs for that in-ground mine. Now, when we look at hybridization, in mining, which has been a thing in mining for a long time because the sites typically are fixed. You can do tethered operation for things that don't move much. So if you have a piece of drilling equipment or a piece of mining equipment that's moving inches an hour, that's a really good case for tethered equipment. And now we have other systems too. So we have overhead catenary systems where you would have a pantograph on the vehicle in order to supply AC power to the vehicle, sometimes DC power to the vehicle. And that then would provide propulsion or tractive force to that vehicle or other operations on that vehicle as well. But generally, when we talk about hybridization, it's really, I think, a step towards sustainability, because when we look at the efficiency of internal combustion engines, on the top side, we're at 35, maybe 40% efficiency of actually getting the energy from the fuel to perform useful work. The rest of it's all waste heat. So in mobile applications, if you're at 35% efficiency and you can apply an electric hybrid system, you can almost double that efficiency in some cases, depending on the application, depending on the type of vehicle, but at a cost. So then that hybridized vehicle not only is burdened with an internal combustion powertrain, it's also burdened with electrification powertrain. And depending on the duty cycle, you could need some really high-tech batteries to do rapid charge and discharge cycles. And so you could either have a very large battery that's very heavy, takes up a lot of room, and you can charge and discharge from that, or you get into very specific battery chemistries that are very expensive to do a smaller battery that's doing very high current charge and discharge. But with that comes that efficiency gain. And with that comes the reduced dependency on infrastructure where you're operating that hybridized equipment.
Yeah, no, that's interesting. You brought up a couple interesting points there. One is that need for infrastructure. When we're talking off-highway equipment, it almost goes without saying that these things are used in places where you do not have easy access to infrastructure. I mean, you can go to top of a mountain in Chile or something, basically, and they're trucking diesel fuel in vast quantities, to make these things work. So I can see how there's a certain appeal there. And you mentioned batteries, which is of course, that's the $64,000 question: is that can batteries be made that are sort of light with high energy density, that are cost effective to make, cost effective to operate? But in on highway equipment, battery weight has been a major problem for a long time, and it's been something they worry a lot about. Is that necessarily the case for off highway? I mean, I've talked to bulldozer manufacturers who say that to get the breakout forces you actually need some mass in the chassis.
Yeah. So there are applications that have ballast, so they'll take extra steel plates in order to provide ballast to give them mass, and those are great applications for weight, for reducing some of that ballast with battery weight. So materials handling, if you think about out in the shipping container yards, all of those large restackers that are picking up a shipping container and lifting it 20 feet in the air have a lot of ballast weight on them. So weight-wise, perfect application to package a bunch of heavy batteries on there. And what we see a lot of the time is more of a volume constraint. And that volume constraint plays into the type of technology that's in that battery. So we'll say the faster you can charge and discharge a battery, the more likely or the greater the risk of an unintentional discharge or an uncontrolled release of energy. And so then in order to protect against that, you have to put thermal barriers in that battery pack that then increase its volume. So you have to figure out a way to mitigate thermal runaway to do high current discharge and recharge. And most of the time that increases the volume of that battery. So there's constant trade-offs, and the people that are doing it well are really sitting there and they're studying what their customer applications are, what their shift cycles look like, to right size the amount of batteries to hit a shift, to hit half a shift and charge on lunch. So there's a lot of considerations that come into making battery decisions on these off-road pieces of equipment.
Yeah. Now, of course, we talked about mass, and mass can be your friend or your enemy in some of this commercial equipment. What about weight distribution? I've talked to some designers in the industry who basically say weight's one thing, but center of gravity is another. Basically, I want to get that weight down as low as I can, but high enough that I also have the ground clearance necessary to make my equipment work. And when you look at batteries, you think, could you distribute that mass around the vehicle in a way that you could maybe make that work for you?
Yeah. So one thing to understand is that the designs today for electric off-road equipment are adaptive designs. So they're taking what they've had for, I don't know, maybe 50 years as far as the shape of the vehicle, the size of the vehicle, and where that center of gravity is, and they're adapting that to an electrified space. So there are considerations with that. But what you want to do when you're packaging batteries is get as many battery cells as you can into one volume, because the fewer of those, we'll say packs or sub packs, the better off you are, the more efficient you are, one volumetrically, size wise, because you have fewer external containers that are taking up space that you have to find space for. So again, it really comes down to, what are your trade-offs? What are your key design considerations? And then at the OEM, what do they value and what do their customers value most? Do they value, having a lower center of gravity, or do they value being able to maneuver into small spaces? You know what I mean? So there's no one size fits all battery. And batteries are expensive. So if you have a battery pack design that works for you, you want to use as much of that as you can to increase volumes of scale, right? And that's where we see, because in the off-road space, the vehicle portfolios are so vast and diverse, there's no golden arrow that suits all of the applications fit. And that really affects the volume that an OEM can generate, because they're trying to electrify multiple pieces of equipment in their portfolio, which means that their overall volume is potentially low, which then increases the cost to the end user. And that's where we get into this chicken and the egg. Yes, electrification is more efficient energy wise. Yes, electrification can meet a lot of sustainability goals, but we're in this chicken and the egg discussion with volumes. As volumes build, as infrastructure matures, there's a lot of balancing act that's made and complex design decisions.
Yeah, yeah. Now it's cost, of course, always rears its head where we have this conversation, and there are many who say, it's too expensive. It's ruinously expensive to design, to electrify large pieces of equipment. It's expensive to build. There's going to be price pressure, on the end user perspective. Others I talk to say, if you go this route, you've got some interesting options. For example, hub motors, or if you imagine planetary gear sets and AC motors, which are designed right at the wheel end for wheeled vehicles, or at the sprocket end for track vehicles. And of course, on the road, unsprung weight's a major problem. It's been an inhibiting factor in using that technology, but there's no such thing as unsprung weight in the vast majority of the equipment we're talking about down here. And you kind of wouldn't mind having that mass down there anyway, would you? So are things like those sort of alternate propulsion technology, that a way to get simplification?
Yeah, it is. It is, absolutely. And you're right. There's a lot of rigid chassis out there that don't have suspensions that would filter the load, or become a sprung mass on a lot of that load. But when we talk about that, there's a double-edged sword there. So for on-road commercial vehicle, an unsprung load would be like 40 Gs versus something that has a suspension on it. That suspension actually filters down to about 5 Gs of load on a chassis mounted piece of equipment versus an axle mounted piece of equipment. So then you need to make those things that are unsprung very robust, and they have to be not just shock and vibration robust, but your axle loading and things like that can change too. So then you get into, again, more bespoke designs. So you couldn't have one wheel hub motor assembly that fit all applications, because your loading is so different on each of those wheels, each of those axles across a portfolio of products. So again, you get into this discussion about, how do we make bespoke designs that are robust but not over designed for some applications and under designed for others. And you can't make it all fit in one. And that's where the large investment in not just the design, but also the capital that's needed in order to manufacture these things cost effectively.
Yeah, yeah. Now most modern equipment, the big stuff especially, a lot of it basically operates on sort of drive-by-wire, fly-by-wire type systems anymore. The idea that you're going to pull on a lever and it's going to cycle a hydraulic valve is pretty much gone. However, in a sense, you end up with situations where you have a joystick control, which is maybe sending an AD converter built into the joystick controller. It sends a signal to a box that processes that and sends a signal downstream to a solenoid that's valving hydraulic fluid. maybe, through torque converters. So you've got this odd thing where we're add layers of complexity in here. There are some who argue that with advanced, sophisticated motor control now, with a battery electric system, you can get rid of a lot of that essentially. And essentially from that joystick control, it says you can actually control power right at the tractive end, and you're not running through torque converters. You're not valving fluids. Basically, could you win back some of the extra cost of electrification by simplification with that?
Yeah, absolutely. I mean, batteries are still a component and the major component of cost for that machine. But you not just win back cost, you also win back efficiency. So if you can do a direct drive rotational with a motor versus a hydraulic motor, you win, right? Because you're not converting electric to hydraulic to rotational energy. You're just going electric to rotational. So that's where you can build business cases for increasing efficiency, kind of like in the hybrid model, right? If I have a hybrid, now I have access to battery power, maybe when the vehicle's not in motion, but I have a battery on board. What else can I do with that energy? That's not just tractive force. Can I use it to run a PTO? Can I use it to perform a work function on a vehicle rather than just using hybrid batteries for tractive force?
No, as you brought up an interesting point, I didn't think about the PTO aspect of this. Of course, in the current world, you've got a PTO and all the gearing and associated sort of shafting responsible for that, and it's clutched. So when you're not using it, it's idle, but you still have the mechanical clutch, which has to, or torque converter has got to engage and disengage it. Could you see a world where PTOs are literally a standalone AC motor, which is just sort of switched in or out as you need it?
Yeah, absolutely. And that's where we talk about today the designs are adaptive. I was working with an agricultural company, and they were bringing a story from one of their customers that were saying, "You mean that rotating shaft out to the back of the tractor? I don't need that anymore. I'm no longer constrained to have that as a means to power my implement." We're like, "Yeah, no, we could just run some wires to your implement and then put an electric motor there." And they were like, "Whoa, that's a game changer. Like now." The architecture of my implement is no longer constrained to that center rotating feature. I can put power wherever I need it. I don't need to use belts, chains, pulleys, gears to transfer rotational energy that's coming in one direction to multiple directions on my machine.
Yeah. Jonah, I'm glad you brought up that ag example because of course, we have to bring that into the conversation. So what about ag? Tractors, combines, sprayers. I mean, various equipment comes to mind. And the one thing we have seen over the last decades is that the tendency is toward larger and larger equipment. Often more wheeled than tracked, but lowest ground pressure possible to minimize soil compaction. These machines are big. They're expensive. Could they be made electric?
Yeah, I think we'll see some electrification. Again, it goes back to that analogy that you were saying. We've got something on top of a hill in a very remote location. Do I have enough? Can I put infrastructure up there? Is my infrastructure going to be stable and my capital investment is safe if I do that, right? Same with agriculture. If we look at the grain belt or the breadbasket within the US, you're talking about massive swaths of land that are use large pieces of equipment to harvest that. So one, there's a couple of considerations when we look to electrify. One, reliability and robustness is key, right? So the farmers and the agricultural companies have to be confident in that equipment that it's going to make hay when the sun's shining, right? And that we're going to be able to harvest the grain when it's time to harvest. So the first consideration when we're talking about ag is that reliability and robustness. Then we talk about infrastructure. That's where hybridization really makes sense. If I can go and get more operation off of a tank of fuel and hybridize a piece of agricultural equipment, makes tons of sense. We're going to see a lot of that in the agricultural industry in the next 5 to 10 years. Strong hybridization, and then also battery electrification. But battery electrification is kind of tricky when you're running 24 hours a day to try to harvest. I mean, you got all the lights on in your tractor. You're going down acres at a time. That becomes a challenge with batteries because you don't want to stop to charge. So then we see that, if we look at more of like a farm, we'll say like a value crop farm, like a blueberry farm, an apple farm. Out here in Sonoma County, we've got a lot of what I call wine trees. Those types of applications for smaller equipment make a lot of sense. The infrastructure is fixed. you're in a site, you can schedule your equipment more efficiently. And so they're electrifying, and doing battery electric makes a lot of sense. And we see a lot of vineyards out here that are doing a lot with electric tractors. And the other thing that will enable, I think, and what we've talked about a lot, is for value row crops, the infrastructure is fixed. It actually, electrifying gets you 5 steps closer to autonomous operation. And with labor shortages, especially skilled labor shortages, like, I don't know if you've seen vineyards, but the wine or the grapevines are planted very close together. And I wouldn't be brave enough to drive a tractor between those 2 rows and not think that I'm not going to do thousands of dollars worth of property damage, right? And a lot of those people that are operating those tractors are actually looking behind them to steer. They're not looking ahead of them to steer. So then we look at electrification. Because it's more expensive, we could start to see offsets when we look at autonomous functionality, because we're reducing labor. So that labor reduction then enables the increase in the cost of that equipment to operate that value row crop.
Jonah, last question, and that is of course, cost has to enter the equation at this point. Is that what are the pacing elements toward full electrification off highway? What is it going to take to actually get the diesel engine into museums?
It takes vision, I think. I think the OEMs have a vision, and they're getting a lot of support from their customers. But again, we're in that transitional phase where the cost of equipment is more than the ICE comparative, right? The internal combustion, the diesel equivalent. And then you have the infrastructure costs. So when we talk about sustainability for commercial vehicles on-road and off-road, it's really about improving total cost of ownership or providing a return on investment that's comparative to its diesel equivalent. And I think we're on the cusp of that. So sustainability is really balancing all those things: cost of equipment, what's the capital cycle, what are my risks to being able to maintain and keep that equipment facilitating commerce for my business, against all of these disruptive or rapidly changing technologies such as electrification, synth fuels, biofuels, hybridization, hydrogen, So I think it's going to take more people buying in that yes, this is more efficient. Yes, we need to deploy these technologies because ultimately the energy equation pencils out. And as energy costs go up, electrification is going to become the sustainable winner.
Great conclusion and a bright future. Jonah Leason, Electrification Product Manager for Parker Hannifin. Thanks for joining me on the podcast.
Thanks for having me, Jim.
That's it for today's Industry Insights and Trends podcast, brought to you by
Parker Hannifin.
If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D Printing, Aerospace and Defense, Digital Transformation, Simulation, or a weekly roundup at engineering.com/subscribe. For our deeper engineering series, visit engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on engineering.com TV. Thanks for tuning in.